Hi, we're going to talk about multiplying. Since this chapter is all about multiplying in algebra, it'd be a good idea to remind ourselves what multiplying is all about. What is multiplication? When we say 3 times 5, for example, what does it mean? One answer is that 3 times 5 means 3 groups of 5. 1, 2, 3 groups of 5. In those 3 rows of 5, we can see there are 3 times 5, 15 objects. When we arrange objects into a rectangular arrangement like this, we call the arrangement an array. Since this array has 3 rows and 5 columns, the dimensions of the array are 3 by 5. Notice we wrote that like 3 times 5, but we say 3 by 5 in this context. We can also group in the other direction. Now we see 5 groups of 3. This shows that 3 times 5 equals 5 times 3. If we make the groups go in the other direction, we're really talking about reversing the order of multiplication. This is called the commutative property of multiplication. Let's talk about that word for a moment. Commutative. The commutative property of multiplication means we can reverse the order of multiplication and get the same result. The word commute in everyday language means travel back and forth. Often the word is used to describe someone's travel to and from work. That sort of makes sense here because the 3 and 5 sort of travel back and forth. Here we have 5 times 3, and we can travel them back and forth and turn it into 3 times 5. That's just a way of thinking about how those numbers sort of commute, move back and forth to connect the regular language meaning to that commutative property of multiplication. It's a way to help remember that term. Okay, the original question was, what does 3 times 5 mean? Another answer is area of a rectangle. Let's say this rectangle is 3 inches by 5 inches. Those are the dimensions again, like we talked about before. The sides of the rectangle, 3 inches by 5 inches, are the dimensions. Area measures surface by counting squares. How many of these squares are there in that rectangle? Since the length is 5 inches, there are 5 square inches along that side. This square that's 1 inch by 1 inch is called a square inch, and there are 5 of them along that side. There can be 3 rows of those squares, so the area of the rectangle is 3 inches by 5 inches, which is 15 square inches. Notice when we write that, we put the exponent 2 after the abbreviation for inches. So it looks like 15 inches squared. This is called an area model for multiplication. What if we're multiplying 3 numbers together, like 3 times 5 times 4? To see what that means, let's look at our 3 by 5 rectangle again. Right now that rectangle is standing up on its side. Let's see what happens when we lay it flat. This is how we represent a rectangle that's lying down. It looks like a parallelogram. Actually, it is drawn as a parallelogram, but it represents a rectangle lying flat. To represent 3 times 4 times 5, we'll start with the flat rectangle. Here's the 3. We had the length of 5 in the other direction. And now we add a height of 4 inches. Maybe you can see that we're building a box. That 3 by 5 rectangle is here, the bottom of the box. And I can build a 1 by 1 by 1 inch cube, a cubic inch, on top of 1 square of that base. I can fit 5 of those cubes along the 5-inch edge. And then we can have 3 rows of those 5 cubes resting on the bottom. The area of that base That 3 by 5 rectangle on the bottom tells how many cubes fit on it. Now, building up, I can fit 4 layers of 15 cubes. 3 times 5 times 4 tells us that 60 cubes fit into that box. That's volume. So the volume of a box can be found by multiplying length times width times height. Or we could say area of the base, that 3 times 5, and take that times the height. If we don't know some of the edge lengths, we might use variables. So the area of a rectangle whose dimensions are a and b would be AB, a times b. The volume of a box with length 4x, width 5x, and height h would be L times W times h. Length was 4x, width was 5x, height is h. 4x times 5x times h is 20x squared times h. What if we start with the number of cubes on the front face of the box? Then I have 5 times 4, which is 20 cubes. There are 3 layers of 20 working front to back, so 3 times 5 times 4 equals 60 cubes, just like before. Notice what we did. First we did 3 times 5 to find the area of the bottom and multiplied by 4. In the second example, we did the 5 times 4 first to get the 20 cubes in the front and did 3 times 20. Of course, they gave us the same answer, but that's another important property of multiplication. It's called the associative property of multiplication. Now, a couple sample problems. We can find the area of this region. We might be asked to find the area of odd-shaped regions like this, but that multiplying only works for rectangles because it's counting the number of squares in each row and column. So what we would want to do is divide this up into rectangles. Could do it like that. That's not the only way we could cut it up. We could have made our divisions going across. But let's look at how we would figure out the area here. I've got 3 rectangles. Each one is going to have a certain number of squares. Then I'm going to add them up. Now the rectangle on the left, this side is 2 centimeters. This side is 12. So our area equals 2 centimeters times 12 centimeters, which is 24 square centimeters. The rectangle in the middle is a little trickier because it looks like this should be 10. But notice 10 is the entire distance all the way across. This is 10. So what's this? What we saw up here, we have 2 centimeters. This part has to be the same. So if the whole thing is 10, this part's 2, that leaves us with 8 centimeters right here. We can use the same kind of reasoning to find this. I can see that this is 12 centimeters, and this part right here is 4 centimeters. So to figure out what's left, 12 minus 4 is 8. So this area is 8 times 8, or 64 square centimeters. And finally, we have the rectangle on the right. We just said this height is 12, but I've got to figure out this side. For that, I need to do a little bit more puzzle work here. I need to look at the top. And I can see from the top that I've got a 14 here and a 2 here. That gives me a total length of 16 centimeters from the left to the right side of this entire figure. Now, looking at the bottom, still got to be 16 total, but this part we said is 10 centimeters. 16 minus 10 would leave us with 6 centimeters. So this area is 6 centimeters times 12 centimeters, which is 72 square centimeters. Then to find the total area, I add those 3 up. Total. Total area is 24 square centimeters plus 64 square centimeters, which is 88 so far, plus 72 square centimeters for a total of 160 square centimeters. One more quick example. At the right, each of the small rectangles has length y and width x. So they're calling this the length, that's y, the width is x. Express the area of the largest rectangle as length times width. Well, if this length is y, the whole thing is 4 of those. That'd be 4y. Since this was x, the entire width would be 5x. 5 of those x's is 5x. So the length times the width would be 4y times 5x. Part B then asks us to simplify the answer to Part A. Well, using the commutative property, I can multiply these in a different order. I can switch the 5 and the y and think of it as 4 times 5 times y times x. And 4 times 5 is 20, so that's 20 yx. Or, using the commutative property again, I can switch the x and y, because it kind of makes sense to put them in alphabetical order. 20 xy. They're the same thing. Part C asks, how many of the smallest rectangles, how many of these make up the largest rectangle? And we can see there's 5 in a row, there are 4 rows. 5 times 4 is 20. What's the area of each? Well, each one has a length of y and a width of x, so this area is xy. And it says explain how these answers are related to the answer in Part B. Well, 20 rectangles, each with an area of xy, 20 rectangles with area xy gives a total of 20 xy square units. Now, previously we saw that we had an area of 20 xy, which we got by doing the entire length and width. So it's good to see that thinking of it as the entire length of 4y times the width of 5x gives us the same answer as if we divided it up into small rectangles and then calculated the area that way. That's our discussion of multiplication. Have a great day.